Welcome to EDU World Space.
Okay, so we have a DEPT 135 spectrum, and we need to use the information about it to determine what structure we likely have. So I would point out one thing about this DEPT 35 spectrum, and that's that it goes up to 210. That's the highest mark on it, right? And that we have, four signals lower on the spectrum. But we don't see anything from around, say, 160 onward. And 160 onward is where we see typically carbonyl stretches, right? However, ketone stretches can be beyond 210. Or, sorry, not stretches, signals can be beyond 210, right? That is, it's very likely that we have a signal that's off the chart here. And the reason I say that is because our other options are that our CNMR for our carbonyl are going to be for a ester or for a carboxylic acid. But carboxylic acids and esters typically range, no higher than like 190, right, to, 150. Right? So if we don't see anything between 150 and 190, then we don't have an ester, we don't have a carboxylic acid. We do, however, know that we have a ketone or an aldehyde. So we can pretty much from that information alone already rule out 1, 2, and 5. Right? It's not 1, 2, or 5, which means that we're left to decide between 3 and 4, which I will now sketch down here. Right. So here's 3. Okay, and here is 4. Okay, and then I would point out we've got 4 other signals. Okay, right, not counting the carbonyl. So how many signals would be in each of these structures other than the carbonyl? 1, 2, 3, 4, 5, right, in 3 versus 1, 2, 3, 4 in option 4. 4 signals in 4, right? And we have 4 other signals lower on the spectrum. So by that rationale alone, we can pretty much already tell that it's 4, but then we can make sure that it also makes sense for what we've got going on. So let's look a little closer at 4 and see if the rest of the DEPT 35 spectrum makes sense. Right, so we've already ruled out 1, 2, 3, and 5. We're pretty sure that it's 4, but let's make sure. So this is a CH3. Right, this is a different CH3, this is a CH, and this is going to be a CH2. Okay, so that makes sense with what we see here, right? We've got 3 signals going up. We know on a DEPT 135, those have either got to be CH3s or CHs, right? But any carbon with an even number of hydrogens is going to be pointing down, right? And that applies to CH2s as well as CH4s, but that's just methane, so we're not likely to see that. Point being that we can basically say that, well, we've got 1 signal pointing down corresponding to our CH2 there, and then the remaining 3 signals pointing up are going to correspond to our other 3 signals, and very likely what we're looking at is that if we call this A, B, and C, that C is going to be the furthest upfield, being the furthest from the carbonyl, whereas B and A are going to be the 2 that are further downfield, and D, let's call it the one that's pointing downward, right? It's right in the range where you would expect a carbon that's bound to either an OH or an ether. Okay, so 4 is our best bet.